Good day, guys. We are now at Unit 4 of IM 101. So, the topic for this week is Components and Functions of Database Management Systems. For our essential questions, we are to answer the following: how does the different elements of a database management system work? How can a database management system help an organization or entity? For our intended learning outcomes, we look at the different components that make up a database system and what are the functions of database management systems that can help an entity or organization in handling and managing data. When we say database system, we are referring to an organization of components that define and regulate the collection. Take note, collection, storage, management, and use of data within a database environment. So inside the database system, we collect, we store, we manage, and we use the data inside, the database environment. So that is basically a database system. From a general management point of view, the database system is composed of five major parts. So they are hardware, software, people or peopleware, procedures, and data. When we say hardware, it refers to all of the system's physical devices. For example, computers such as workstations, PCs, servers, and supercomputers, as well as storage devices such as your flash drive or hard disk drive or SSD or NVMe drives, network devices such as hubs, switches, routers, fiber optics, and other devices, as well as automated teller machines, ID readers, so on and so forth. Okay. When we say software, although the most readily identified software is the database management system itself, which could be, let's say, for example, MariaDB, PostgreSQL, MySQL, Microsoft Studio SQL or MS SQL, SQLite. Okay, those are the most readily identifiable software, which is the actual database management system. But aside from that, to make the database system function fully, three types of software are needed. Okay, not just the DBMS software. We also have the OS or operating system as well as application programs and utilities. The OS manages all hardware components and make it possible for all other software to run on the computer. Example of OS are Windows, Linux, Mac OS, Unix, MVS. Okay, we also have iOS, Android, or any other operating system. Okay, for the DBMS, as I have said, the examples that I have stated are the following. So I will not repeat that anymore. And lastly, application programs and utility software are used to access and manipulate data in the database management system and to manage the computer environment in which data access and manipulation take place. Application programs are most commonly used to access data found within the database to generate reports, tabulations, and other information to facilitate decision making. Utilities are, on the other hand, software tools used to help manage the database system's computer components. Okay, so application programs can include websites, can include actual applications that you make in inside your computer using Visual Studio, using PHP, using JavaScript, using Python, Java, or C Sharp, or any other programming language. So basically, the application programs can be made by you, or it could be installed from the internet, or it could be accessed from the internet or through CDs or DVDs. Utilities, on the other hand, they are the one that manages the computer components. These utilities make maybe utilities that are used to monitor the memory, the storage devices, the backup devices, as well as network resources. Okay, those are samples of utilities. For the people or peopleware, it includes all users of the database system. Take note, all users of the database system are under people or peopleware. Based on primary job functions, 5 types of users can be identified in the database system. They are the system admin or administrators, which oversee the database system's general operations. The database admin or administrators, also known as DBA, which manage the database and database management system, ensuring that the database is functioning properly. We also have database designer, which designs the database structure. They are in effect database architects. If the database design is poor, even the best application programmers and the most dedicated DBAs cannot produce a useful database environment. We also have the system analysts and programmers, which design and implement application programs, which in which they design and create the data entry screens, reports, and procedures through which end users access and manipulate the database data. And lastly, we have the end users, who are the people who use the application programs to run the organization's daily operations. Okay. So basically, for example, here in Canvas, we are the end users. We are the one that supplies data or manage. We are the one that uses Canvas in order for us to run the daily lecture operations of PLB. Next component, we have the procedures. So procedures are instructions and rules that govern the design and use of the database system. They are critical, although occasionally forgotten, components of the system. They play an important role in a company because they enforce the standards or rules by which business is conducted within the organization and with customers. They're also used to ensure that there is an organized way to monitor and audit both the data that enter the database and the information that is generated through the use of those data. Then lastly, we have the data. So it covers the collection of facts stored in the database. They are the raw material from which information is generated. The determination of what data are to be entered into the database and how those data are to be organized is a vital part of the database designer's job. So we have figure 15, the database system environment. As you can see, we have the people or peopleware. We have the hardware. Okay. We have the software. We have the data and the procedures. Okay. Take note, all of the following entities interact with each other except for the hardware, which actually is the one housing our software and our database management system as well as our data. Okay, what are the functions of the database? First one, data dictionary management. When we say dictionary, what term comes into your mind? Okay, so dictionary, through the dictionary, we can find the meaning of a word. So basically, the database management system provides the meaning to our data. So it is a data dictionary. DBMS stores definitions of the data elements and their relationship called metadata in a data dictionary. In turn, all programs that access the data in the database work through the DBMS. It uses the data dictionary to look up the required data component structures as well as relationship, thus relieving you from having to code such complex relationship in each program. So through data dictionary, we can relate or we can have relationships inside our data as well as define the data found in our database. Okay, so as you can see in figure 16, we have a table. So let's call this as employee table. So all data that is found here, okay, is specified or interpreted by the data dictionary. As you can see, if you have been able to use Access in your earlier years in computing, you might be familiar to this particular layout. Okay, so we have the column, the data type, and the description. So the column or the column name is found as header of our table, whereas the data type tells us what type of data is located in that particular column. So nbar char pertains to string, int is integer, char is character, and then date is data type. And then we also have the description describing the particular column. Okay. Data storage management. The DBMS creates and manages the complex structures required for data storage, thus relieving you from the difficult task of defining and programming the physical data characteristics. It is also important for database performance tuning. Performance tuning relates to the activities that make the database perform more efficiently in terms of storage and access speed. So we have here figure 17, the diagram for the data storage management. So it includes what? It includes DBMS helps provide the snapshot and mirroring of our database, which is related to backup recovery and failure. What happens when our database suddenly gets corrupted or malfunctions? We have storage virtualization, how the memory and the data storage is handled in our database. We have compression. So compression relates to how the data is compressed and uncompressed to and from the end user. Going back to the database, we have the volume migration. So when we move our database from one system to another or from one location to another, we have process automation, automatically doing processes intended, such as, let's say, for example, automatic backup, automatic copying of data, triggering of certain events. We have disaster and recovery, which is uh, also related to snapshot and mirroring. Okay, replication which could also be intended for volume migration or disaster and recovery or snapshot and mirroring. And then we also have auto provisioning, which is automatically increasing the size of our database as well as the memory of our database. We also have the following function: database transformation and presentation. DBMS transforms entered data to conform to the required data structure. It relieves you of the chore of making a distinction between the logical data format and the physical data format. Take note, logical data format is the representation of the database that we see, while the physical data format is the representation of the database in our actual computer. That is the DBMS formats that physically retrieve data to make it conform to the user's logical expectation. Security management. It also creates a security system enforcing user security and data privacy. Security rules determine which users can access the database, which data items each user can access, and which data operations they can perform. So we can actually limit a particular user to, for example, we want that user to have read access only. Okay, we can do that inside our DBMS. Multi-user access control. It provides data integrity and data consistency. DBMS uses sophisticated algorithms, ensuring that multiple users can access the database concurrently without compromising the integrity of our database. So multiple users can use the same database, the same table, or they can view the same data without compromising the integrity of the data found in our database. Backup and recovery management provides backup and data recovery to ensure data safety and integrity. DBMS systems provide special utilities allowing the database administrator to perform routine and special backup and restore procedures. Recovery management deals with the recovery of the database after a failure, such as a bad sector in the disk or power failure. Data integrity management. DBMS promotes and enforces integrity rules, minimizing data redundancy and maximizing data consistency. The data relationship stored in the data dictionary are used to enforce data integrity. Okay. So data integrity is very important. Why? Because that when the term integrity is spoken, what idea comes into your mind? So that is legit, that is true data, that is verifiable data. Okay, that is integrity. So we also have data integrity rules. Basically, they are the rules that can be applied to tables in order for us to enforce different types of data integrity. So we can set rules to our database objects in order for us to make sure that the data coming out and going in our database are having integrity or are verifiable. Okay. Database access languages and application programming interfaces or API. The DBMS provides data access to a query language. A query language is a non-procedural language. When we say non-procedural, we are the ones specifying what must be done. Okay, basically we just tell uh, the database what must be done. We do not have to specify how it is to be done. So, for example, it's like this. In a non-procedural language, we just tell that you need to cook rice or you need to fry an egg. Okay? But in a procedural language, in order for you to cook rice, what must be done first? First, you get the rice from the rice container. Next step, you measure the rice. Next step, you wash the rice. Next step, you add water relevant to the amount of the rice. Next step, you put it in the rice cooker or in your gas stove. Next step, you must watch or take care that the rice will not be burned. Next step, okay, the rice is cooked. So that is the difference between non-procedural, wherein the user specify what must be done, and procedural, in which we specify the steps in order for an output to be done. Okay, so database or DBMS uses non-procedural language, structural query language to be exact. So structural query, structured query language rather, is the de facto query language and data access standard supported by the majority of DBMS vendors. Basically, guys, although there are countless number of DBMS software, as I have said, there's Maria, MySQL, Oracle, Postgre, etc., etc. Because they are following a de facto standard language, which is SQL. When you master one particular DBMS, you can easily migrate to another DBMS. All the major commands such as insert, update, delete, and select, as well as create, drop, are all found in all of the DBMS uh, programs, okay, DBMS systems. They are using one common syntax, one common logic. However, there are instances that because they are different vendors, some commands or some syntax are executed differently. Okay. If we are to have our lecture in advanced database system on your later years, you will uh, notice that some commands are different from one database vendor to another. Okay. Next is API or Application Programming Interface. API is a language and message format used by application program that allows to communicate that allows the application program to communicate with the operating system or with the DBMS or communication protocol. Okay, basically API, through the use of API, for example, although you have created your program in one language, we can allow other languages to access your database. So say, for example, I created an API which has a standard format, standard rules, and then that API can be accessed by C Sharp, by Android, by iOS, by web applications. Okay, just one particular API, but it is accessible to different application programs in order for them to communicate with our database or with our OS or with our communications protocol. Lastly, we have database communication interfaces. The current generation DBMS accept end user requests via multiple different network environments. Okay, so basically guys, that's it for our lecture in Unit 4. Okay, thank you and see you soon.